Hello everyone, and welcome back to another Eng 130 video tutorial. In this tutorial, we're going to cover an extra example of the method of sections. And really, there isn't really any tricks to this example that there wasn't in the last example. As you guys will see with trusses, it's always fairly straightforward, and if you know your sign conventions, trusses aren't going to give you any troubles. So, by the end of this example, you should hopefully have a good grasp of the method of joints and the method of sections, and that's it. If you have a good idea of what to do for both of those, when you get to the final question will actually be very easy. It's worth 10 marks, so 25% of your final, and you should just be able to breeze right through it. The one thing that I've seen students do wrong on the final is what I've been kind of telling you guys a lot is just the signs, the sign convention. One negative will mess up everything else in your truss. So make sure that you know how to do support reactions. And then when you're doing the members, make sure that you always have the correct sign convention, because saying if it's in tension or compression is going to be very, very important. But with that being said, let's just go through this example. It should be nice and easy. And yeah, all right, let's begin. Alrighty, so looking at this example, it wants us to determine the forces in members HG, HE, and DE of the truss, and then of course, state if the members are in tension or compression. So very straightforward. Basically every question you've seen before. So let's pretend that this is a final situation and they can say this exact sort of question. They're going to want you to determine the forces in some members. Now the trusses in the final are usually pretty big trusses. We're not going to give you something simple because you guys will get it right away. As I said, trusses, they're not that hard to do, and as you guys have seen, not that hard. So what's going to happen in the final is they're probably going to give you a big, large, complex truss, and instead of asking you to solve for every member, they're going to ask you to select a couple members and solve them. And remember what I said, if the members are close to the end of the truss or a support, that usually means the method of joints. If the members are in the middle of the truss, well, that's probably a good hint it's the method of sections. So in this example, what it would like us to do is to determine members HG. So let's find HG and just highlight it. So this is HG. HE, so this is the one coming down diagonal, and then of course DE, and this is the horizontal member at the bottom. So this one's kind of tricky, but we can just do real quick to try and find out what method we should do. So in order to get to those members, we need to get to point G or point E. Well, actually we'd have to do both. To get to those ones using method of joints, well, we're going to have to start at F and then work our way over. So it's definitely not crazy bad, but I would not recommend it. What happens is the only time in the final, so I'm going to highlight some members real quick. The only members in the final that you would want to use the method of joints for would be members GF or EF, or say KJ or AJ or AB. If it's further than that, I would always just try and cut the beam. And remember what I said, I like to highlight the members because it usually shows the way I can cut. So if I'm highlighting those members right there, then my cut is actually going to be pretty obvious. It's going to go right down the center. It cuts through all three of those members. And again, I have to check. I have three equations, so therefore I must have three or fewer members in my cut. And if I look, I got 1, 2, 3. I can easily cut that. It's good to go. And I can actually solve for everything. So I'm going to just erase the check marks real quick. I'll go back and highlight these. So now we have to determine, oops, that's not what I wanted to do at all. So now I wanted to determine, okay, I know where I'm going to cut. Now we have to pick a side. Because remember, when we cut something, we can analyze either side. And kind of the rule of thumb, pick the easier side. So if I look at this, there's two sides. There's the left side, which should be everything in this area right here. And as you can see, that's a lot of stuff, pretty gross. I'm not going to do that. Instead, I'm going to look at the right side, because if I look here, not a lot of stuff. Very, very few things actually. But even if there was more things on this side's the better choice. And the reason why, there's no support conditions. So if I look at my supports, we got K on the left side, and we got A on the left side. So if I'm analyzing the left side, which you can do, we're going to have to know the supports at K and A. And this question is kind of a big hint telling you we're not going to do the left side because it gives you 2 pins. And what that basically means is you guys can't solve it. There will be 4 unknowns. You guys don't have enough equilibrium equations to solve for that. And actually you'll have to go into some other things such as compatibility and stuff to solve that, which you guys are not expected to do. So it's kind of a big hint, don't do it. So what we're going to do in this scenario is analyze the right side. And since there's no support conditions in this side, we don't have to solve for any support conditions. So we can go right into the cut. So when I cut something, I like to put the line I cut. So for this one, we got 1, 1. So I'm going to say cut the member, cut the truss, I guess, not a member, because I'm cutting through the members. Cut the truss along line 1, 1. So if I do that, well, the first thing I want to do is I want to draw all the members that stayed uncut. So members that are just going to be by themselves. So if I look here, I got a member going up, which is GE. I got EF coming to the side. So I'm going to highlight these points here so you guys know exactly which one. So this right here would be E. On this side, I got F. I got a diagonal member going between the two, or not between those 2 points, but I got a diagonal member here, which goes from G to F. And if I look, that's it. Those are the only members that are left untouched on that side. I see that I have some external forces, so I got a vertical load both at E and F, so I'm going to include those right here. So vertical load at E and F. And remember, we're keeping all these examples SI, so we're not going to worry about imperial. So all I'm going to do is, instead of saying 1,500 pounds, I'm going to say 1,500 newtons. Then I'm going to do that for both. 1,500 newtons. All right, I got my external forces. The next thing I'm going to have to include, of course, is the members that I cut. So if I look at joint G, I cut through member HG. So if I look up at the diagram, I cut through this member right here. So I'm going to have to replace it with a force. So remember, I always want my force to be in tension. That's how I kind of help make sure that my sign convention is always going to be correct. Remember, trusses are simple. The only thing that'll start getting a lot of students is they're going to get a negative wrong somewhere, and that's going to mess up everything along the way. And it's really, really, really tricky to try and find it once you've gone too far. And I mean really tricky. It'll take you a long time. And if you're in a final situation, it's just not going to end well. So I'm just putting another truss that I cut through down here. Truss member DE, which is right there. And then finally, I cut through HE, which is a diagonal member right here. So I'm going to go from point E up. So this can be my diagonal member. And I'm going to label this one HE. And since it's diagonal, one of the best things to do too, of course, is just label its vertical and horizontal span, so we can figure out the angles associated with it. So we know it goes 3 in the horizontal direction, 4 in the vertical. Well, 3, 4, we know that the hypotenuse is going to be 5. So we're almost done. The last thing that we're going to want to do is just include the dimensions of the member that haven't been cut. So we know that the horizontal span there is going to be 3 feet. But we're keeping it SI, so I'm going to put 3 meters. And then along this side, we know it goes up by 4 feet. But again, I'm going to switch it to meters just to make it SI. You guys will not be tested on imperial, so why include it? So this is our free body diagram. As we can see, it's actually pretty nice, pretty simple. We have 3 unknowns, and of course, we have our 3 equations. So everything's going to be just fine. So where will we start? Well, usually taking a moment's the best place because we can try and get rid of 2 of those forces and solve for one of the unknowns directly. So if I take the moment right now, I see if I take it at point E, which I just highlighted in pink, it'll get rid of HE and DE. So that sounds like a pretty good place to take a moment, get rid of 2 of those things. So I'm going to take some of the moments around point E is equal to 0. So if I'm looking at this equation right here, what I'm going to have is HG is going to create a moment. So I'm going to have HG. And the distance between HG and point E is 4 meters. So I'm going to have a 4 here. And if I look, it's going to create a positive moment. So I'm going to leave it. That's perfect. And then what else creates a moment is going to be this 1,500 newtons at the far end. So I'm going to have 1,500. And it's at a distance of 3 meters from point G. And if I look, it creates a negative moment, so it's going to be minus, and that's it. So everything must equal 0 because of equilibrium. And when I solve this, I get HG is equal to, 1100, I guess 1125, that's kind of hard to say, newtons, and it's a positive answer, so it means that the member is in tension. So it's very important to include that T for tension into the final answer. That's one thing that we'll be checking for marks. I would tell you guys a lot in the first half of the course, units, units, units. Well, I'm pretty sure I drilled that into your head now, so now when it comes to trusses, I'm going to tell you the tension, 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 or compression, compression, compression. Very, very important. You guys will lose marks, and I don't want you guys losing marks over something so simple that you guys could have easily have gotten. So I look back up at the diagram now. Well, I see that if I go sum of the forces in the x direction, I'll have two unknowns. One of them will be HE, the other one will be DE. So that's probably not a good place to start. So I'm going to go sum of the forces in y, because I see that the only thing that I'll have a component in y is HE. So I can solve for that directly. So if I come down here and I go summation of the forces in the y direction is equal to 0, and I go through my thing, I see that I have two 1500s going downwards. So I'm going to have minus 1500, minus 1500. And then I have HE going up, and it's the only one. So we're going to have plus HE. And remember, HE is diagonal, so we only want its vertical component. So if we look at this case, we're going to take its span in the y direction, or the vertical direction, which is going to be 4, and we're going to divide it by the hypotenuse, which is 5. So over here, we're just going to go 4 over 5. And we know that this must be equal to 0 because everything is in equilibrium. So we come down here, we solve that equation, very, very easy. We see that HE is going to be equal to 3750, so 3,750 newtons. And again, we get a positive answer, therefore must be in tension. So what I'm going to do, I'm going to box that answer, HE. Kind of put this down a little bit. And there we go. We already have two of our unknowns. Very, very easy now, because the last thing we can do is sum the forces in the x direction. Normally, it would have 3 unknowns, but since we solve for 2, it's only left with 1 unknown, which is great for us. So what we can do is come down, sum of the forces in the x direction is equal to 0. And if we do that, what we see is we have HG going left, so negative HG, so negative, and then the value of HG we know is 1125. We come up, our next one is HE, it's also going left, so negative HE, which we know is 3750, but we only want its horizontal component, so in this case it's going to be the 3 over 5. And if we look up again, we got DE, and it's also going to the left, so we're going to have a minus DE. And all of this must be equal to 0. And if we check, the only unknown that we have in this equation is DE. So when we solve, we find that DE is equal to 3375, so 3,375 newtons. And when we solve this, we actually get a negative answer. So what that means is this member is actually in compression. So I'm going to highlight this really quick. And there we go. And that is our answers. So as you guys can see, the method of sections, very, very nice when we're trying to find a couple members that are in the middle of the truss. We don't have to analyze a bunch of joints. For me, analyzing the joints usually isn't too bad. The thing I hate most about analyzing the joints is drawing all those stupid free body diagrams. It gets really, really annoying. And of course, you mess up in one joint, you're going to mess up everything after that. So for me, I like the method of sections. It's very, very good. Usually in the exam, you'll probably have a combination. If this was the exam question, they'd probably ask for you to solve for those members that we just solved for. But then they might also ask for, let's say, KJ and AJ, something like that. So that's a nice method of joints way to solve for them. But in this example, just wanted those 3 members. We can easily cut through them. Good to go. So that's it for this video. In the next video, we're not going to solve a truss, but we're going to look at a complex truss and just try and figure out, are any of these members zero force? Meaning, can I eliminate some of these members before I begin the analysis? And that's very important because that's what they like to do in the finals. They'll give you a complex truss that looks very hard to solve, but if you know that some of those members are equal to 0, then you can solve it right away. Perfect. And it's actually usually worth quite a bit of marks. And it's funny because what they teach you in the class on how to find zero force members doesn't really apply to what they do in in the exam. They usually throw a little trick in there. So I'm going to show you guys that trick. Well, actually, there's 2 of them. And from there, we're good to go. So thank you guys all so much for watching, and I'll see you guys in the next video.